Hi, now we are going to discuss in detail about Spark execution planning. We will understand that once we submit the code, then how does it gets converted to unresolved and resolved logical plans? What is the role of catalyst optimizer? How does it create physical plans? And based on the cost model, how does it decide the best physical plan? So all these things we will discuss in detail. So let's get started. So let's say we have written a code. It can be in Spark SQL, PySpark, Scala, or whatever language is supported in Spark. So our code, when we submit it to the driver, so first of all, it creates a unresolved logical plan. By logical plan, what it means is that it just create a high level flow of the code. Like I will do this first, then this, and maybe some conditions and all. So a high level flow it creates. And that is unresolved. By unresolved, it means that it has not yet checked whether the table and the columns which are mentioned in the code, do they really exist or not. And that information about the table and columns exist in the catalog. So catalog, depending on the environment, it can be Unity catalog if it is Databricks, or it can be Hive Metastore if it is Common Spark, which is the default Metastore, or it can be any other catalog also, depending on the environment where we are using Spark. And so it reads the information from the catalog and confirms that the tables and columns that we have mentioned in our code, those really exist. And then it creates the resolved logical plan. So by this step, it is confirmed that all the tables and columns are existing in real. And if it doesn't find any table or column, at this step itself, it will fail the code and we will get the error. It will not even start executing the code or planning further. After the resolved logical plan is ready, then comes the catalyst optimizer. So as the name suggests, it is a optimizer. It takes our code, and within the catalyst optimizer, there are some predefined rules are there. For example, if there is a filter, we are applying it after a lot of operations. So what it will do is it will push that filter to the first operation, so that in stage 1 only all the data is filtered out, and in the rest of the stages only the required data goes. So this is one example rule. So there are so many rules defined here in the catalyst optimizer, and by default all the default rules works in a best way, but we can customize them also if required. So we can extend the class and then we can write our own rule also if we want to optimize in our way. But by default, based on the set of rules, it optimizes the code and it rewrites that code. So that is the power of catalyst optimizer. And after catalyst optimizer, we get the optimized logical plan. So now it has the plan which is resolved and which is optimized in terms of coding. So then what it does is, now like it has the final code, so it will prepare physical plans. And by physical plan, what exactly is meant by, it creates a detailed plan like how many partitions it will create of the data, which type of join it will use, and how many executors it is going to push the data to. Like that, how actually it want to execute the code. So it prepare multiple options like plan 1, 2, 3. It prepares multiple plans there, and out of all those options, it runs that plan through a cost model. So in the cost model, it decides like out of all these options, what is the most optimized way, which is expected to be performant when we actually execute the code. And at this stage, it uses the table statistics also. So from the table, like it fetches like what is the min max value of the columns, what is the total count. So all those things are available in the table. It fetches that data, and that data and the other data related information based on the code, it processes, and then all these plans it do some process and check like how much cost will be there and how much time it will take. So depending on that, it selects the best physical plan. So after it select the best physical plan, now it has the final code or the final plan which it is going to execute on the actual cluster. So then it sends the code of that final best physical plan to the cluster, and then the actual code gets executed. So this is how the flow works end to end. So we submit the code. First it prepares the unresolved logical plan which doesn't have the column names or table names verified. Then it verifies those that info from the catalog and prepares resolved logical plan. Then catalyst optimizer, it optimizes the code based on some predefined rules which are customizable, and then it prepares the optimized logical plan. After that it prepares all these physical plan with different options, runs through the cost model, decide the final best physical plan, and then execute that code on the cluster. So this is how internally Spark does all the planning, and this way before executing the code itself, it is able to prepare the final code and final plan which will be very much optimized. So that's how the planning looks like within Spark. So that's it for now. Thank you. Bye.